Lesson 8-1, and in this lesson we are going to graph systems of equations. Objective of this lesson: to solve systems of equations by graphing and to determine whether a system of equations has one solution, no solution, or infinitely many solutions by graphing. Why is it important? Because you can graph systems of equations to solve problems involving business and geometry. Let's take a look at this application on world records. Cape Verde is a group of islands located off the westernmost point of Africa. In December 1994, Frenchman Guy Delage set off from these islands for a 2,400-mile swim across the Atlantic Ocean. That's a long swim. He arrived at Barbados in West Indies 8 weeks later. So every day he would swim a while and then rest while floating with the current on a huge raft equipped with a fax machine, a computer, and a two-way radio. Okay? So this is the map of this. This is Cape Verde. And then he swam all the way to Barbados, which is 2,400 miles, okay, across. Okay, so people are already considering trying to break Guy's record, but before a challenger makes an attempt, he or she should know what is required. Guy traveled approximately 44 miles per day. Okay, a good swimmer like Guy can swim about 3 miles per hour for an extended period, and the Atlantic currents will float a raft for about 1 mile per hour. Okay, to match Guy's record, how many hours per day would one have to swim? Okay, so how many hours would one be able to spend floating on the raft? Okay, now to solve a problem like this one, I don't know if you want to match what he did, but to solve a problem like this one, okay, let S represent the number of hours Guy swam, and let F the number of hours he floated. Then 3S represents the number of miles he traveled while swimming, and 1F represents the number of miles he traveled while floating. Remember, he swam approximately 3 miles per hour, and the raft floated an hour. Okay, 1 mile per hour. Okay. So the number of miles he traveled while floating. You can also write two equations to represent this situation. Okay. So this is those two equations. The number of hours swimming plus the number of hours floating is the total number of hours in a day. And the other equation, number of miles while swimming plus the number of miles while floating, is equal to the total miles in a day. So these are your equations. So S plus F, represented by number of hours swimming for S, number of hours floating for F, will equal the number of hours in a day, which is 24 hours. And then we go to the second equation. The miles traveled while swimming will be 3S, okay, plus the miles traveled while floating will be 1F, will be equal to the total of miles traveled in a day. So these are your two equations, okay? And the equations S plus F equals 24 and 3S plus F equals 44 together are called a system of equations. The solution to this problem is the ordered pair of numbers that satisfies both of these equations. What it's saying is this: if you find an ordered pair for S and F, and they both satisfy or both make both equations true, then that is the solution, okay, for this particular system of equations. Okay, and one method for solving a system of equations is to carefully graph the equations on the same coordinate plane. Okay, the coordinates of the point at which the graphs intersect is the solution of the system. So we need to graph both of them, okay? And then after graphing both equations, where they intersect will be the solution of the system, okay? And if you can see, Delage's raft is not actually, okay, a simple raft, okay? So it's quite complicated. It has solar panels, source power, and all of that. Okay. So let's go back to our problem. With most graphs of systems of equations, we can only estimate the solution. Okay. So in this case, the graph of s plus f equals 24 and 3s plus f equals 44 appear to intersect at a point with coordinates 10 and 14. Okay, now we will use GeoGebra to graph this. To graph s plus f equals 24 and 3s plus f equals 44. Let's first graph 3s plus f equals 24. Okay, using GeoGebra. So if you use GeoGebra, okay, and instead of s plus f, we'll do x plus y. Okay, so we have x plus y equals 24. That one, yeah, I think x plus y equals 24. So we're just changing the variables, but it's the same thing. Okay, and then we get the other one, which is 3s plus f equals 44, or 3x plus y equals 44. Okay, so if we put that there and we graph both of them, remember, okay, how to graph. Before I show you the graph of this one, remember how to graph each of the equations. Okay, for example, if we have x plus y equals 24, to be able to graph that, you need to equate that to y and use mx plus b. Okay, the different methods of graphing, using the chart, using point slope form, and using y equals mx plus b, or the intercepts, finding the intercepts. And if you graph those two equations, let me show the grid here. Okay, show the grid, and let's open it up. Okay, this is now the graph of your two equations right there. Okay, and if you notice, let me get that, put it in the middle right there. Let's make it bigger a little bit. There it is. Okay, if you notice that point right over there, right here, okay, that point right over there, okay, is the intersection of both graphs. Now let's go back to our problem. Okay, so that means it appears that the intersection of both graphs is 10 and 14. Let's verify that it's 10 and 14. Okay, look at this, it's 10, okay, and very close to 14. So that's the intersection of both of our graphs. Let's make that point and see if it's really 10 and 14. Okay, and here line B. Let's do a point. Yes, very close to 10 and 14. 10.9, 13.74, approximately that that point right over there. So going back to our lesson here, so they appear to intersect at a point with coordinates 10 and 14. Okay, and let's check if 10 and 14 satisfies both equations. So in each equation, replace s with 10 and f with 14. So we have s plus f equals 24 will be our first equation. Substitute that with 10 and 14. Obviously, it will check out. And the other one is 3s plus f equals 24. Substitute that with 10 and 14 as well. And you end up with a true statement as well. Okay, so the solution of the system of equations of s plus f equals 24 and 3s plus f equals 44 will be 10 and 14. So the ordered pair 10 and 14 means that a person trying to match Guy Delage's record would have to spend approximately 10 hours a day swimming and 14 hours floating. That's a lot of water time. Okay? Now let's take a look at example number 1. Graph the system of equations to find the solution. I always advise you, when you are solving these types of problems, you number your equations. Make this equation 1 and make this equation 2. So you know right away that you're dealing with the systems of equations, and when you're trying to solve for the system of equations, you won't be confused with uh, any of those equations. Okay, so x plus 2y equals 1 and 2x plus y equals 5. So again, we graph equation 1 and equation 2 using the methods that we learned by using a chart, okay, or the ordered pair method, the table. We can also use the x and y intercepts, okay, to graph that. We can also use the point slope form, okay. We can also use slope intercept form, okay. So these are various methods wherein we can graph these two equations, okay. And when we graph these two equations, okay, again I think we're going to go back to GeoGebra here. Yes, we are. Okay, so we go back to GeoGebra and let's clear this, okay, and let's not save this, okay. And if we input the equation x plus 2y equals 1, okay, so x plus 2y equals 1, this will be our graph right there, x plus 2y equals 1. And then if we get 2x plus y equals 5, 2x plus y equals 5, this is what we're going to get right there. Okay, let me move this a little bit so you can see the two equations. X plus 2y equals 1 is this one right here. Okay, and 2x plus y equals 5 is this one right here. Okay, and if you notice, it appears that they intersect at this point right there. Okay, now let me just put it in pen right there. And that point looks like it's 3, negative 1. So that point looks like it's 3, negative 1. So the point where these two lines intersect will be 3, negative 1. And let's go back to our lesson right here. Okay, so it looks like it appears that they intersect at 3, negative 1. The graph appeared to intersect at point 3, negative 1. Okay, and then check this estimate by replacing x with 3 and y with negative 1 in each equation. Now, if you notice, it's saying check this estimate. This only shows you one thing, that when you are using this system to solve for the system of equations, when you are using this method, the graphing method, to solve a system of equations, it is not an exact science. Okay, and that's the reason why it's saying check this estimate, because you can make a mistake when you graph this. So check this estimate by replacing x with 3 and y with negative 1 in each equation, and let's do that right now. Okay, check x plus 2y equals 1, replace 3 and negative 1, substitute 3 for x and negative 1 for y. You end up with a true statement, and if you use the other equation, 2x plus y equals 5 for equation number 2. So again, this is equation 1, okay, which we tried, and this is equation 2. So we'll try equation 2. Substituting x and y, we end up with a true statement as well. So we have verified that the solution to our system of equations is 3 and negative 1, and we use the graphing method. Okay, and there are other methods that we will learn after this lesson. Okay, this is just the first one. So from there, we move on to what we call inconsistent and consistent, okay, systems. So a system of two linear equations has exactly one ordered pair as its solution when the graphs of the equations intersect at exactly one point. And that is best exemplified in example 1 and the Guy de Lage example. They both intersect at only one point. So if the graphs coincide, okay, when they say coincide, that means you have a line, okay, and another line, on top of the same line. There you go. Okay, that's what it means when they say the graphs coincide. They are the same line. Okay, so when if the graphs coincide, they are the same line and have infinitely many points in common. In either case, the system of equations is said to be consistent. So again, let's recall what was just said. So if you have a system of equations, okay, which intersect at one point, or which coincide or have infinitely many points as a solution, it is said to be consistent. The system is said to be consistent. Okay, so that is at least one ordered pair. It has at least one ordered pair that satisfies both equations. Okay, take note of those terms. Those will come out on the test. Okay, so it is also possible for two graphs to be parallel to each other. In this case, the system of equations is inconsistent because there is no ordered pair that satisfies both equations. Remember, when two lines are parallel, such as this one, I'll give you the same example. If I have two lines that are parallel to each other, these two lines will never intersect. And let me make, let's say, I put it on a graph here. Okay, so let's say this is my graph right here. Okay, and I have two lines that are parallel to each other. These lines will never intersect. Okay, that means there is no solution. Okay, and this system is considered to be inconsistent because there is no ordered pair that will satisfy both equations. Okay, so another way to classify a system of equations is by the number of solutions that it has. Okay, for example, if a system has an infinite number of solutions, it is dependent. And if a system, okay, let's do the first one. If a system has only one solution, it is called to be independent. Okay, now independent and dependent systems are only, okay, consistent systems. Okay, they cannot be inconsistent because inconsistent systems have no ordered pair that satisfies both equations. Okay, so thus the system in example 1 is said to be consistent and independent because, okay, it has one solution, and that makes it independent, and at the same time, following the definition of a consistent equation, okay, it has at least one ordered pair that satisfies both equations. Okay, so example 1 is a consistent and independent. Okay, and this chart right here summarizes the possible solutions to systems of linear equations. Okay, the first one, if you have intersecting lines, therefore the number of solutions would be exactly 1. The terminology would be consistent and independent. If you have the same line, which means two lines coincide, okay, they have infinitely many solutions and is said to be consistent and dependent. And finally, you have parallel lines, no solution for parallel lines, therefore this system is simply inconsistent. Okay, know the terms, okay, and write this down in your notes. So graph each system of equations to determine the number of solutions. Okay, you have x plus y equals 1 and x plus y equals 4. Okay, so equation 1 and equation 2. So the graph of the equations are parallel lines because obviously they have the same slope. If you solve for this one, okay, you end up with, if I put this in the form of y equals mx plus b, this becomes y equals negative x plus 4, and this becomes y equals negative x plus 1. And if you notice, the slopes now are the same. Negative 1 and negative 1 are the slopes. So therefore, they are parallel lines. Since they do not intersect, there is no solution to this system of equations. Okay, that means they are inconsistent. It is an inconsistent system. And after you graph that, this is what you get. Okay, they have the same slope, but they have different y-intercepts, which makes them parallel. Okay, so recall that the system of equations that has no solution is said to be inconsistent. Let's take a look at the letter B. X minus y equals 3 and 2x minus 2y equals 6. Okay, so again, let me give you a hint here. If I get this equation right here, okay, 2x minus 2y equals 6, and I divide both sides by 2, remember, the equation will not change because I did the same thing. Whatever you do to one side of the equation, you need to do to the other side for the equation not to change, for it to be the same. So what I just did is divided both sides by 2. I end up with x minus y equals 3. If you notice, these two equations are the same. And you guessed it, okay, when you graph these two equations, okay, they have the same graph, okay. That means, okay, if I graph them, they will coincide, okay. One line will lie on top of the other line. Therefore, there are infinitely many solutions for the system of equations, okay. So notice in this case, in letter A, they have the same slope but not the same y-intercept. In letter B, they have the same slope and they have the same y-intercept. Okay? And this is said to be consistent, and the system is said to be consistent and a dependent system. Okay? And if we check our answer, we need to verify that 4, 1 lies on both lines. Okay? We simply substitute it back to our equations. 4, 1. We find out that it will make both equations true. Okay? Let's take a look at the next one. And the methods you use to solve algebra problems are often useful in involving geometry, and these are the problems that you will be doing in high school, using algebra to solve geometry problems. Okay? Look at example number 3. The points A, B, C, and D, okay, are vertices of the quadrilateral, okay, and then use the graph to determine the point of intersection of the diagonals of a quadrilateral A, B, C, D. So when you talk about diagonals, the diagonal of a figure, okay, attaches two non-adjacent vertices. So when you have a vertex and you have another vertex, provided that these two vertices are non-adjacent to each other, okay, the line that connects them is called your diagonal. So that's the diagonal for AC, and this is diagonal for BD. Okay, so what is it asking? Okay, use a graph to determine the point of intersection of the diagonals of the quadrilateral ABCD for letter A, and find the equations of the lines containing the diagonals to verify the solution. Okay, so first things first. Okay, letter A is pretty simple. After we do that, draw a quadrilateral ABCD with diagonals. That's what's here. Okay, and the diagonals appear to intersect at point 2,5 right there. Okay, and then to check the solution, find the equations of lines AC and BD and verify that 2,5 is a solution for both equations. And we remember how to find the equation of a line. Okay, after of course finding the slope. So first things first, we need to find the slope. Y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Let's find the slope of line AC. Line AC is right here. That means you have the points negative 1, 6 and 8, 3 to consider. So we use the formula for slope. M equals 3 minus 6 all over 8 minus negative 1. And we end up with a slope for AC as negative 1/3. And then let's find the slope of BD. And we are now considering the points 4, 8 and negative 2, negative 1. Okay, finding the slope. Okay, negative 1 minus 8, negative 2 minus 4. Using the slope formula, end up with a slope of 3/2 for BD. Okay, now we found the slopes. Okay, we use the slope-intercept form y equals mx plus b to determine the equation of each line. Now, do you only use y equals mx plus b? Of course not. You can also use point slope form to be able to find the equation, okay, of that line. Okay. In this case, we're using y equals mx plus b. So let's find the slope for line AC. Okay. So y equals mx plus b. Let's write that down. And the slope is, okay, negative 1/3. Substituting point, okay, in this case that is point A. Okay, so we used point A, which is negative 1/6. Let me write that down. Okay, so A is negative. Let me redo that again. Negative 1/6. That's point A. Okay. Yep, that's point A. So 6 equals negative 1/3 times negative 1 plus b. We simply substituted the x-coordinate and the y-coordinate. We find the value of b to be 17/3. And we get that value of b, okay, and substitute it back to y equals mx plus b. The equation is negative 1/3 x plus 17/3. And then let's solve for equation BD. Again, y equals mx plus b. And then we substitute the slope, which is 3/2, okay, and use the point 84, which is, 48, which is point B. So we're using point B, okay, to find the equation for this line, which is 48. Substitute those values, okay, to x and y. Okay, you now have 8 equals 3/2 times 4 plus b. Okay, the value of b will be 2. Then we simply substitute the y-intercept back to y equals mx plus b. We end up with y equals 3/2 x plus 2. Okay, now we found both equations. We now get the point where they intersect, which is 2, 5, and find out if they form a solution. Okay, if it will make both equations true. So let's get 2 and 5, substitute back to y equals negative 1/3 x plus 7/3. Okay, simplify that, we end up with a true statement. And we get 2, 5, and substitute it to equation y equals 3/2 x plus 2. Okay, we end up with a true statement as well. Therefore, the solution checks out. Okay, and the secret word for this lesson would be Broncos. Secret word would be Broncos. Okay? And that's our lesson. Thank you for watching.